Great. Thanks, everyone. I'm Anant Agarwal, and I work at Instacart. And today I'm going to be talking about how we run Temporal at Instacart and how it is kind of a backbone, really, today in most of the platforms that we have. Little about me. I joined Instacart a little under 3 years ago, right after, I believe, the second wave of the pandemic during COVID. And I joined in the infra platform team and was part of the team that brought Temporal to Instacart. So kind of worked all the way through in setting up all the abstractions that I'll talk about today and all the different ways different teams at Instacart is using Temporal. And I live in the SF Bay Area, which, if that wasn't obvious. So my presentation today is going to be divided into 3 parts. The first part is going to be talking about why we needed like a temporal kind of a system at Instacart. And the part 2 and part 3 is more about what kind of abstractions that we have actually built at Instacart and how we have kind of grown the scale of Temporal at Instacart and just popularized it through different orgs that we have in the organization, our advertisement platform, our fulfillment capabilities, our actual Instacart app and the marketplace. And then we do a lot of the infrastructure work through Temporal as well. So talking about Instacart's Temporal journey. So we started evaluating Temporal 2.5 years back, right around the time I joined as well. And this was after the second wave of the pandemic where our systems were being put through like multi-fold scale traffic just because of the nature of the time at that point. And at the same time, there were a lot of new use cases coming up from our payment services, from our advertisement platform, where they wanted to explore the possibility of doing things in like a more workflow as code primitive. So if we take a very canonical example of an Instacart order and what happens behind the scene when you press checkout. So your card gets translated into what we call as a batch that gets sent out to multiple shoppers. One of the shoppers picks up the batch, goes to the actual store and starts doing the shopping for the items that you have. And at the same time, he's talking to you about possible replacements, telling you about, this is not available, do you want something like this? Then they come to your house, they deliver your order, and then they go ahead and then, you go through the customer feedback cycle. So this is kind of like a maze of, or a graph of like different business processes. And each different business processes has kind of a different failure semantics around it. They have different retry capabilities, and they have different like need for signals or just waiting for like some kind of an input. There could be like an even smaller example, for example, adding like a new payment or just creating like a new profile. And as and when our systems were going through that scale and new use cases were coming up, we soon realized that our current plumbing and stitching together of Airflow jobs and Sidekick jobs and bunch of custom stuff here and there just wasn't going to cut it for us. Instacart was a very big Ruby shop initially when it started out. So a lot of our like customer-facing marketplace capabilities and our fulfillment capabilities are written in Ruby. However, we have soon, we are kind of pivoting to like a more of a polyglot use case. So our entire advertisement platform is built on top of Golang. A lot of our batching fulfillment capabilities is written in Python, and most of our like internal tooling, our infra capabilities, they are also in Python. So kind of coupling that, taking all of that together, we soon realized that our current architecture and our current systems just had very limited visibility into what was going on. We had very limited retry capabilities and error handling capabilities. At the same time, like Airflow is really good at what it does, mostly like data ETLs, but it's not really good for like mission critical latency sensitive applications. And then there is a kind of high latency and slow execution that Airflow and some of the other systems provide, which we simply just outgrew them. So we started doing the evaluation of like a more formal workflow engine. We considered a lot of alternatives, even considered building one ourselves, which we actually very quickly ruled out because just the amount of time and investment that it would take, it was just too much for us. We looked at AWS simple workflow functions and then step functions. While they were good because we are a big Amazon shop, and it would have played really well, and it was a managed offering. We ruled it out because it had a limited Ruby support at that point. I believe their Ruby flow framework was deprecated or was in the process of being deprecated. It didn't have like the best UI, like the best CLI, according to us, and at the same time, it didn't have like a very good local execution, like dev test kind of capability, at least if you're not going to directly touch Amazon servers. Cadence and Temporal were pretty interesting. The founders had like so much of vast experience around building technologies like this. So we were kind of like thinking more about them, but then we chose Temporal over Cadence, one, because Maxim and the team, they kind of just went ahead and created like an open source project, which was receiving very active development. And at the same time, it had gRPC, which was like the main protocol we was using at Instacart. And Cadence, I believe, at that point, I don't know about today, it was on Thrift. So it would have been like a pretty big difference for us. And then if it wasn't clear before, we are a polyglot shop. So we have like a huge Ruby code base, a huge Golang code base, at the same time, a very big Python code base. So we wanted to support all languages, all systems running like at critical scale. And then we kind of went with Temporal for those reasons. And as when we started building out some of our initial use cases, we started getting like a lot of wins in terms of just handling that scale. It was a re-architecture for most of our systems. We went through that exercise, but then how easily it fit into our systems, we were able to get the scale. And then I'll talk about the abstractions that we built to kind of make that process easier. Those were like really immediate wins for us. So I'm going to cover a little bit about what has happened since then. So 2.5 years ago to today. Some of my next slides will cover it, but we are running around 20 namespaces, and a namespace for us is just like a use case. We are running like 11 million workflows per day through Temporal, and at different parts of the organization, whether it is our fulfillment systems, whether it is our marketplace systems, our checkout process, our data infra process, our like CI/CD pipelines, and just our advertisement platform, Temporal is there somewhere. So I'll talk about the data quality check system because I recently built that. So right now I work at the data platform team. We completely rewrote our own data quality check system to write like data integrity checks and like business assertion checks against all the different data sources that we have. So Snowflake, Postgres, ClickHouse, Dynamo. So we kind of wrote a system completely built on Temporal, a lot of like cron schedule and signaling workflow here. It runs like based on a user specified cadence through a YAML, and then we kind of run it against different data sources. Our payments reconciliation process, which was one of the initial use cases for which we evaluated Temporal, now powers all of our like orders and the payment capabilities. This is a mix of Golang and a little bit of Ruby because it had to fit into like a Ruby monolith. And then this is kind of powering all of our orders and all the payments. I believe we also wrote like a new payment gateway service to kind of look at different payment providers behind the scenes and run our payments through them. I talked about our advertisement platform. So all our display, ad, creative, and the entire life cycle of like any kind of an image or any kind of an asset that our CPG providers, think your Coke, your PepsiCos, PG&E, Unilever's, all of what they provide, entire life cycle of that is controlled through a temporal-based system. A lot of, again, signals being used here because you need a lot of approvals, and they happen at like different times. And then Instacart's entire CI/CD pipeline is powered by Temporal workflows in the back. A lot of Python code here. Our service provisioning workflows, again, all use Temporal. Our database provisioning workflows all use Temporal. And there's just like very rapid growth of Temporal on the infra side of the world. So going on to how we use Temporal and so this is going to be the bulk of my talk. So one thing, if it wasn't clear, at Temporal, we don't have like one big use case. We have like so many different use cases. And then it has been a journey to kind of grow that kind of a usage of Temporal. And then we were able to do that because we built certain abstractions. We built a lot of tooling, which I'm going to share with you for the rest of my presentation. So looking at numbers, we've been in production for 2.5 years, running close to 11 million workflows, 19 workspaces. And our largest and the busiest namespace, it's running close to 6 million workflows. And these numbers are a couple of weeks old when I wrote the slides. I'm sure it will be more than 6 million now. Entire batching operation is being done by Temporal. We have around 200 worker types. And in our 2.5 years of running Temporal, we have had less than 5 incidents and no Sev 0 or Sev 1 incident. And most of those incidents have been because of workflow versioning at large scale. So I'm going to talk about how we deploy Temporal. So we are an Amazon shop, and we use Amazon's ECS runtime. So ECS is Amazon's container runtime. You deploy services as like ECS tasks, and you can scale them out independently. One of the good things ECS has is you kind of create an ECS cluster for what we kind of do in our org. So like we created an entire Temporal ECS cluster. It has certain CPU memory, certain other configurations on top of it. And we self-host Temporal. So we deployed all of the core Temporal services, the front end, the matching service, the internal worker, and then the history service as like separate ECS tasks so we can scale them out and then size them separately. We put an ALB in front of it, which then is being used by the UI or the admin tools service, and then which eventually our developers access. One of the good things by running it in its own ECS cluster is that it allows us to control the security and the networking to the very low level. So we only open up access to certain ports, certain services. Otherwise, it stays pretty tight. Then the green and the pink boxes that you see on the left, they are basically workers that our end customers, so like different teams at Instacart use to run the Temporal workers. So they run them as ECS tasks as well. The pink one could be like our customers cluster, the green could be our ads cluster, and we just allow connection over specific ports, over specific protocols, just to the Temporal cluster. And for an Instacart developer, they mostly interact with Temporal either through like the SDK or through the UI, which again gets through the ALB that we have set up. Most of the management, or like the internal, the platform team, the Temporal platform team does, is they also use the Bastion service if they want to use like tcuttle commands against Temporal. We use Cassandra as our backing store, which I think we get from a vendor. And then we have Elasticsearch, which we use Amazon's OpenSearch alternative. So one of the things you'll hear me talk a lot about today is just abstractions. So we grew to a large scale at Instacart. We have like different parts of the organization using different things. One of the things I think we have done really well is we kind of built out middlewares in different programming languages, so be it Golang, Python, or Ruby. And then we have this habit of building like wrapper SDKs, which historically has helped us a lot, and in Temporal's case has definitely helped us a lot. So we wrap Temporal's worker primitive around our own SDK just to make sure it plays well within our infrastructure, the monitoring or the logging library that we use, the metric or the tracing systems that we have built out, and then we run them through our own middleware language, which has evolved and which runs pretty much all the major services at Instacart. And I mentioned we run it on Amazon ECS. And in order to run it on Amazon ECS, we again developed some of our own libraries that allows us to like have a lot more visibility into the deploys, a lot more visibility into like the entire CI/CD process of how the worker behaves when you merge a code change. And one of the other things we have given our all the Instacart developers is that we've given them a lot of abstractions to make worker deployment easy. So since we self-host, we take care of like by we, I mean the platform team takes care of the Temporal servers, and our end customers just care about the workers. So at Instacart, we are like an infrastructure as code. We follow the infrastructure as code design philosophy, and we use Terraform a lot. So we ended up doing is we created a Terraform module, which makes it really simple to deploy Temporal workers, which is basically the code that you see in front of you. Internally, we are running it as an AWS ECS task, which again is through our wrappers. But then what you see here is like you define your namespace, you define your task queues, any kind of environment variables you want, any timeouts that you want throughout the life cycle of that particular worker. And then you specify like the system configurations, amount of core memory, and the cluster that you want to run it in. So it becomes really easy for someone to spin up a new temporal worker. At the same time, anyone who's trying to scale it out, who's trying to reason about what the worker is doing, it's pretty much contained in this block of code that you can see. So one of the interesting things that helps us when we are building out these abstractions is that we can control the life cycle of something like a timeout from the moment it is sent by the infrastructure layer, which is Amazon ECS, to the point where it is received by the core worker primitive, which is written by the team here at Temporal. So a very simple example. So whenever an ECS task is running, and Amazon sends typically like a sig term signal, so which is basically telling your process, hey, you have 120 seconds at max to live. So whatever you want to do, you want to finish up in that time, and handle that sig term in a graceful manner, so you're able to, in the context of Temporal, just basically heartbeat out your activity. So in case folks are not aware, Temporal has this design pattern called heartbeat activities, where your activities are just heartbeating out the progress that they have made up till a given point. And then you kind of want to handle that gracefully. It is kind of like a snapshot, and then you can close down your workers in a graceful manner. So our middleware layer also has its own timeout, and then there is a timeout which is on the core temporal workers. So our general philosophy is the ECS timeout has to be greater than our middleware timeout, which has to be greater than the core temporal worker timeout. And it kind of propagates in the way that that's there in the diagram. It also gives the temporal worker enough time to cancel and gracefully exit all the context in the case of the worker. I believe in the case of the Golang worker, it kind of stops all the channels and gracefully dies out. And when I say gracefully, these are just primitives that you might have designed as like post hooks or anything that you want to preserve the state before it returns a sig kill. Because the moment Amazon like ECS sends a sig kill, there's no determinism as to what is going to happen. Like it might be a few milliseconds delayed, it can be a few milliseconds ahead, and you just can't control your worker or your activity shutting down gracefully. So that was on the infrastructure side of things. As I mentioned, we are a polyglot shop. So we started out by looking at all these SDKs. We have use cases in all three SDKs. Our Ruby SDK usage is a little bit low. And one of the first questions that we faced when we were introducing Temporal to the community at Instacart is whether to wrap the SDK or not. So if we were not to wrap it, we would have, like the velocity would have increased. The problem with that was it would have added a lot of friction, because what that meant is teams going out and doing things their own way. So they might use like a Golang driver to talk to, let's say Datadog, which is our monitoring and our logging and observability tool that we use, or doing something else in Python if they wanted. Again, at Instacart, we have a lot of libraries and wrappers already written to kind of streamline all of that. And then one of the advantages of writing wrappers is that if, let's say, tomorrow you want to swap out a vendor, you can easily switch it below the wrapper and your end customer's code doesn't have to change. So we kind of soon realized that we might take a little bit of a time to get the SDKs ready, wrap them up, make it compatible with how we run things at Instacart, because it is going to help us in the long run. Plus, as like platform teams, we want to give like a very consistent experience. And then we want to have control over, we want to draw opinions over how teams use temporal servers that we self-host. So it kind of also adds a little bit of control to us at the SDK layer if we wrap SDKs and kind of swap out different places, which I'm going to highlight in the next slides, so that we form the opinions and just it's easier for teams to use it. So a very simple example is something we implemented at our SDK layer is we implemented this concept of registry. So very simple registry pattern that you might have seen other places. You run it as a singleton. What we're doing is we are saving, we're creating a map that just maps a task queue to an activity and a task queue to a workflow. So what that allows us to do is, like, first you have a very consistent view of what task queue is going to run on what worker, and then by that extension, what activity or what workflows are going to run on what worker, so that if you want to run, let's say, a beefy worker for a specialized set of workflows or activities, you have a very easy way to control it just in the context of that worker. We have implemented the same patterns in all three of the SDKs that we write. The second thing is logging. Now, one of the great things about the SDKs that Temporal has is that it's easier to wrap them. Plus, it's also the programming language having that support. So one of the things that we have wrapped is we have wrapped the logging capability for the workflow and the activity with our own wrappers. We have augmented that by adding more tags to the logging. So the activity ID, the run ID, the workflow run ID, the workflow ID, and a couple of other metadata fields. What that helps us is, one, we know the exact debugging protocols that we have to follow. The runbooks are very, very consistent. And at the same time, to our end customers who are running not just temporal workflows, but maybe an RPC application, maybe some other internal worker asynchronous process, they get the same feel of their debugging process because we have kind of wrapped everything nicely to play within our systems. So a similar thing about the way we do metrics. So we provide our own APIs for sending out workflow metrics and activity metrics, which are replay safe. We build them over the core primitives provided by the Temporal SDK. And then all our end customers actually go through this same process. We have the ability to add different tags. So normally, whenever we deploy a service, all of our service have like tags on the core Datadog metric, which we kind of mandate, like from an infrastructure point of view. It helps us track cost. It helps us, track if there's like a rogue metric, which can eventually lead to like us identifying that a workflow has gone rogue or like an activity has gone rogue. And when I say rogue, it's just like 10-fold or 20-fold increase in that particular metric, which then has like a strict cost implication. So overall, providing wrappers on top of like any low-level primitive given by the SDK has actually helped us a lot in just keeping things consistent. When we started giving Temporal out to different teams, we have like a dev deployment of Temporal, and then we have a prod deployment. So a dev deployment is basically, as you say, for like developers playing around with it. Our VPNs have access to our dev environment. So like through your laptops, you can actually talk to the Temporal server, which are running in our dev environment. You can't do that in production. We have kind of locked it. And one of the things that we have given our developers is the ability to create namespace, username prefix task queues. So then what that means is, like, if in the same namespace in development, you have like your actual development workflows running, which some automation has kicked off, and they're talking to the workers running in Amazon, you then can share the dev namespace by running the workers on your local laptop, either through Docker or like some other system. And the task queues and the workers are actually going and talking to the dev namespace. So because each of the task queues are prefixed by your username, it becomes easy to kind of load balance. Your actual workers are kind of safe. No one is going to mess with that. And then it becomes easy to just give this like as a developer experience. We have since evolved this into also providing Temporal Lite as part of like our developer onboarding documentation and like the boilerplate examples we have. So this use case is probably going to die out a little bit, and then Temporal Lite is probably going to be 100% in a matter of months. I'm going to talk a little bit about monitoring, because I feel like with a system like Temporal, at the scale that we run it, we self-hosting it, we managing like the persistence layer, all the services at Temporal. Monitoring and alerting is like very, very critical, and we treat monitoring as a first-class citizen. So what we have done is we have, again, abstractions, something that you'll hear me talk a lot about, is we have built a lot of useful dashboards that our teams use. And at the same time, we have created abstractions around core monitoring artifacts that any end user of a temporal workflow would need to kind of make sure their use cases are running healthy. So hopefully this is visible. So what I'm highlighting here is like two main dashboards. The one on the top is our main temporal platform dashboard. So I couldn't get everything to fit in like slides, and I just didn't want to roll on about it. So I've captured the main headings that we have. So what essentially we are doing here is like, this is mostly for our platform team just to look at the health of temporal. So very high-level metrics. We capture the metrics that we get from our Cassandra layer, which is through our vendor. We capture metrics about replay testing, which again, I'm going to talk a little bit towards the end, but definitely be replay testing. We measure the amount of errors we have caught because of replay testing. Some metrics on workflow archival, if those are enabled. System metrics, just how much CPU memory, latencies are there in each of the core temporal services, the front end, the matching, the internal worker, and the history service. Measuring metrics around the ALB, so like right at the ALB layer, who is accessing it, what is like the success ratio, your different HTTP codes. And then also like high-level metrics at the namespace layer, at just the volume of activity and workflows, just so that if, let's say, there's an incident, we have like a very complete picture in one space, which is segregated by different service that Temporal has, different namespaces, different environment. The one you see on the below is one that we have created for namespaces. So for each namespace, we'll actually tell you what is the schedule to start latencies for your different workflows, then the different task queues. What is the failure rate based on activity, like at the activity level, at the workflow level, and that's just giving you like an overall stat around the number of scheduled workflows, the number of finished workflows, failed workflows, and same for activities. So just everything being in one place. And then we kind of maintain all these dashboards, so our end customers just have like monitoring artifacts ready for them to monitor. And talking about abstractions, so our end customers are actually running workers, and all they care about is their namespaces, their task queues, and their workflows being staying healthy. So we wrote a Terraform module that allows you to create Datadog monitors, which is our choice of monitoring and alerting solution. And then it takes like very simple inputs that you see here. It takes your namespace. It takes like the Slack and the Opsgenie handle that you want to use for your alerting needs. You can either create monitors for all the task queues that you have. You can control what is like the warning or the actual alert threshold for like different workflow monitors or activity monitors. And then you can actually use them together to just create like a set of monitors that you want to use to monitor your workflows. So that's kind of like how we run Temporal. Now I'm going to share like some key takeaways that have helped us grow our Temporal deployment over the past 2.5 years. So the first one is, again, abstractions. Kind of hitting the point there again. I think one of the reasons why we have been so successful and our Temporal adoption has been so smooth is like we built a lot of capabilities in our SDKs. So our SDKs actually have a lot of control that allows us to play really well with all like the supporting systems we have at Instacart, be it like metrics, tracing, our cloud provider, and all the error reporting work that we do. And we have actually wrapped not just the worker, but the activities and the workflows as well. So it kind of gives like a very seamless experience to our end users. And then one of the other things that kind of helps is like it makes us writing documentation and less like boilerplate helper examples in like a very straightforward manner, which then becomes very easy for our teams to adopt. The next one is like again, as I mentioned, we invest in a philosophy of infrastructure as code, and we use Terraform. And the combination of using like Terraform modules and then creating these abstractions on top of it for like our Datadog and alerting layers, or just running temporal services, has actually helped us a lot control the end-to-end experience and just make it really easy and really quick for like our end customers to start deploying temporal resources. So one takeaway is like, if there is a possibility for your organization to explore, setting up Terraform or cloud foundations, definitely invest in it. It just makes the experience really easy. And the third key takeaway I've alluded to at different places in my talk is replay testing. So workflow versioning and sending out workflows that cause non-determinism errors has been the main source of errors that we ran into and the most serious incidents have actually come out of that. Gladly, Temporal has a solution for it called replay testing. But then the problem becomes that how do you enable your end users to adopt it easily? Because you can't go in and change everyone's code. Or you can build like an abstraction that makes it really easy for them, or you just build tools that make it really easy for them to not be replay testing. So just to give a bit of context, what exactly is non-determinism and why replay testing is important, is if you take the example of the first workflow, it's running an activity, all well and good. Now you decide to make a change to it, and you just replace your code by switching out the original activity with the new activity. Because Temporal works on the primitive that it tries to replay the entire workflow on top of like the execution history, that will now fail because the workflow definition has the new activity on it, but the old event history has the original activity on it. So you'll run into a non-determinism error here. Now the Temporal SDKs have solved it. So the Python SDK provides this capability of patching a new activity, and the Golang SDK, I believe, has the workflow version, which kind of solves the same problem. So it allows you to roll your new workflows in a versioned manner, which then makes it easy for you to run like different versions. And eventually what will happen is your old version will die out, they'll finish. This is especially important for like long-running workflows, and then your new version is going to take over. And the solution to this is basically replay testing. So at a high level, what replay testing is, you download your event history for your workflow, and then you use the replay testing, the replayer APIs that Temporal provides, and you run the new workflow definition on top of that workflow history, and then that is going to catch non-determinism errors. Now, in order to make it easier for our end users to adopt, we actually wrote our own event history scraper. So it takes a namespace as an input. The scraper then goes to Temporal, uses the APIs to kind of fetch all the event histories for specific workflows or all the workflows, and then store it in S3. Because we have, again, abstracted away our own SDKs, what we have done is we have introduced the capability of running replay testing using that S3 bucket and all the event history that is in there. So for you to just run replay history, it is these few lines of code that you have to write. You need to call our wrapper APIs on top of the replayer with the workflow name, or optionally the namespace name. And it is going to take care of talking to S3, fetching the history from there, and then running your workflow on top of it, so that it becomes really easy for you to replay test. The other advantage is that you can now embed all your replay tests in your CI/CD pipelines, so then you can always be replay testing. So this has been like a really big, this has solved so many incidents for us, so many potential bugs, and we highly encourage everyone to use these capabilities that Temporal provides, and then just make sure you provide it to your end customers in whatever is the best way possible for you. So that's the end of my talk. And before I take question, I just wanted to say, while I had the opportunity to present all this amazing work we have done, there is like a big team at Instacart who has been developing all of these systems, and who have just been very important to growing our adoption of Temporal at Instacart. Now time for questions.